Hello, viewers. Welcome to another session of our preparatory e-learning class. In today's class, we shall be looking at the subject mathematics, and the topic is logarithm. Please, if you are just joining this class, if you are just viewing this class, please go to our YouTube channel. We have done a whole lot. We started with indices. We looked at the laws of indices, and we had solved a lot of problems on indices. So now we're going to look at this topic, logarithm. So please, if you are just viewing this lesson, please do well to subscribe and click the notification button so that as we continue to upload our videos, you will be seeing them. And the topic that we have for today is logarithm. I believe you must have heard of this topic before. So what we're going to do now, we're going to reintroduce the topic to you and then solve some JAM or WAEC past questions that will help you in your upcoming JAM or WAEC exams. So what is logarithm? By definition, the logarithm of a number n to base a, written as log n base a, raised to obtain n, is raised to obtain n. Now, how do we solve that? For example, if we have log n base a equals to x, how do we obtain this value n? Now, look at this. If you have log n base a equals to x, if you are asked to find the value of that n, there is a law of log that has to do with that. But for you to solve this, what do? You can now write n is equals to what? Whatever you have here, it will come as a power on the base. So you now have a power x. So this is the expression on how to find any variable that is there. So log of n base a equals to x, for example. To find the n, what do? You move the number to come on the base, and that is that. Let's look at the laws of logarithm that we have. We have a whole lot of laws. We have addition law, we have subtraction law, we have power law, we have a whole lot of laws. Now let's see how we can take the laws one after the other. Now the first law that we have is addition law. Addition law, and in this law we have, for example, if you have this expression like log x to base a plus, because of addition, log y to base a, how can we simplify this logarithm? Now there are conditions that you must take note of, and the conditions are: number one, for this law to hold true, there must be no coefficient here. You must not have a coefficient like 2. You know, this log, a number that is behind this log is called a coefficient. But of course, we know that there is an invisible 1 there. But on the other hand, it is also noted that it is assumed to be that there is no number there. So the condition is that you must not have a number behind the log. And condition number 2 is that the bases must be the same. If the bases are different, the law does not hold true. Now we solve this. You write one log and one base. Because of plus, what do to these numbers? You multiply them. X times y, you have x, y. Anytime you have addition law, what you do to the numbers is what? Any number you have here and you have here, they multiply themselves. So you have that. Let's take an example. Okay, let's look at this example 1 to apply the law of logarithm number 1, which is addition law. Example 1 is what? You have log 4 base 10 plus log 25 base 10. Of course, you can see that in this simple application of the law, there is no number here behind the log. No number is here behind the log, and the bases are the same. When the bases are the same, what do? To solve this, you write one log, one base. Now, because of addition, you multiply the numbers you have there. 4 times 25. When it is addition law, multiply the numbers that you have there. Now multiplying this, we have 4 times 25 is what? We have log 100 base 10. This is base 10. Now to simplify this further, there are laws, other laws that will take us on how to solve this. But solving this, let's just finish up. We have log 100. How do we simplify log 100 base 10? First, you break down 100 to 10. How do we do that? Look at here. Simple division. You break down 100. 10 goes to 100, you have 10. And 10 goes here, you have 1. Now, what do we have here? 10 power 2. So in place of this 100, we bring in log 10 power 2 base 10. You can now see we have a base here, we have a number here that looks like the base. Now this power that is here, you move it behind the log. Now, so that you can have log 10 base 10. How do you do that? When this 2 is moved here, you have 2 log 10 base 10. Now note, there's another law that says when the number here and the base here are the same, such log of the number is 1. So a whole of this place you have here, a whole of log 10 base 10 is now 1. So you have here 2 times 1, which is what? 2. So a whole of log 10 base 10 is 1. It could be, even if it is log A, base A is the same thing as 1. It is a law of logarithm. We are just using it to apply in solving this example 1. So the next law now is the subtraction law. So how do we express this subtraction law? We have, if we have log x base a, because of subtraction, minus log y base a. How do we simplify that? Now to solve this, anytime you have something like this to solve it, you pick one log, one base. Because of subtraction, you divide these two variables. You divide x by y. So because of minus, you divide. When it was addition law, you multiply. So please take note of that. And don't forget the conditions must be met. The conditions are the numbers here must be 1, or you must not have a number appearing behind this log. That's condition number 1. Condition number 2 is that the bases must be the same. When you are certain those conditions, then you can apply the law by writing one log, writing one base. Now from x and y, because of subtraction, you divide them. X divided by y. Now let's apply this law to a simple example. Okay, that is a simple example that we can apply this law. Example is log 28 base 4 minus, because subtraction law, log 14 base 4. Now, how do we solve this? The same approach, the same method. Now, you can look at this that there is no number here behind the log. Condition 1 is correct. And the bases are the same. Now that the conditions have been met, we now have to apply this, to solve this now. What do? You write one log and pick one of the bases, right? Now for the numbers you have here, 28 and 14, you divide them. 28 divided by 14. Why division? Because of subtraction that we have there. Now how do we solve that? We continue by having it as log base 4. 28 divided by 14 is 2. Now we have log 2 base 4. To solve this further, in logarithm, you try to make the number that is here to be the same as the base, or you make the base to be the same as the number. That is by simplification, so that you can have the same base and the same number. So how do we do that? Let's see how we can break down base 4 to also have 2. Now we have log 2. In this base, we have 2 power 2. You know, 2 power 2 is 4. Now, when you have power on the base, when you have power on the base, what do? You move the power on the base behind the log. But in this case, any value you have here as a power on the base coming behind here will come as inverse. Will come as inverse. That means this is going to become, these two coming here will become 1 over 2. 1 over is inverse. If it was 3, you have 1 over 3. If the power was 4, you have 1 over 4. Then you write the rest of the things you have there, log 2 and this base 2. You can now see that the number and the base are the same. So what do we have there? To solve that further, we have 1 over 2 times 1. Don't forget that log of a number 2, that the base is the same, 2 is what? 1. This whole of this is 1. So you now have 1 over 2 times 1, giving us what? 1 over 2. So that is a simple application of subtraction law. The next law we have here is law number 3, which is the power law. Look at this. Because of this powered n that is here on this x, which is assumed as a number, is the reason why we call this power law. But how do we solve this? We have already applied this in our previous simple application to addition law and to subtraction law. But in this, to simplify this, since we have n here as the power, what do? Move it behind the log. So what do we have there? This is going to be n log x base a. That is how to simplify that. That is our power law. Now to apply an example there to solve, for example, example 1, if we have log 8 power 3 base 2, how do we apply this law in this very simple example? Now what do we do there? This 3 you have here is the power, which is just like this n. Now to simplify this, you move this 3 from this 8 to come behind the log. So we have this 3 leaving this place, it comes behind the log. So what do you have there? You have 3 log 8 base 2. Solving this further, you know that the number here and the base are not the same. So what do? You reduce or you break down this number 8 to look like the base. How do we do that? It's simple LCM, like you have 2 divides 8, you have 4. 2 divides 4, you have 2. And 2 goes to 2, you have 1. How many 2 do we have? We have 2 power 3. So in place of this 8, we write what? 2 power 3. So we have this 3 is still there. Log 2 power 3 base 2. Now, how do we solve this further? You know, normally we now have another power on this number, which we still have to apply our power law by bringing it behind the log. Now, solving this, we have 3. This first 3 is what I've written here. This other power here will come and meet this 3 here, but it is coming to multiply this other 3. So the first 3 is this 3. The power 3 coming here is this 3. Now you have log 2 base 2. Log 2 base 2. Now what do we have there? You multiply this and this. 3 times 3 is 9. Log 2 base 2. And don't forget, anytime you have log of a number that the base is the same as the number, the whole of the log and the number and the base is 1. So what do we have there? A whole of this gives us what? 1. Now we have 9 that is here times 1 for a whole of this, giving us what? 9. So that's the answer for that simple application of power law. Okay, let's look at law number 4, which is called power of the base law. Now, how do we represent this law? Look at it here. You can see there is a number here as a power on the base. Now, in this case, how do we simplify this? How can we move this power 2 here out of the base? Don't forget the other law was what? Power of the number law. Now it's power of the base. Now, how do we do that? To simplify this, to remove this number, you take it out from here, the power, it will come behind the log. But in this case, it is coming here as inverse. 1 over whatever number that you have here. So this is going to be 1 over 2 log x base a. You can see when it was power of the number law, moving it here, that number remains the same the way it is. But when the power is on the base, moving it out of the base, you write it as an inverse, 1 over whatever power that you have. If it was power 3, you write 1 over 3. If it was power 5, you write it as what? 1 over 5, and still maintain log x base a like you have there. Now let us apply a simple example to this law. Okay, this is a simple example that we can use to apply this law. You can see that 3 now is the power of base 2, and we have the number here as 16. Now, how do we simplify this? Don't forget, first thing first, you move out this power 3 from the base. It will come behind the log, but as an inverse. Now, when these 3 leave this place to come behind the log, it becomes what? 1 over 3 log. You write the log, write the number 16, and the base here is now 2. We have removed this 3 from here. It comes behind the log. And as it is coming, it is now 1 over 3. How do we continue to solve this? This is our 1 over 3 log. We simplify 16. You can see now 16 is bigger than the base. You reduce 16 to look like the base. What is 16? We have, if we break it down, 2 goes to 16, 8. 2 divides 8, you have 4. 2 divides 4, you have 2. And 2 divides 2, you have 1. We have 2 into 4 places. So in place of this 16, we have 2 power 4. And then the base 2 comes down there. Now, to simplify that, we now have 1 over 3. Take notes, this is now another power, which we have to take it out from that place. Now, what do? This is the other law that we had already looked at. You move it out from here to come behind the log. And as it is coming to meet 1 over 3. That means it is coming to multiply 1 over 3 behind the log. So you now have this 1 over 3 is this times the 4 coming here is still 4. Mind you, when the power is on the number, like this 4 on this 2, as you are moving it out from here, it comes and remains here exactly as 4. But when the power is on the base, as you are moving it behind the log, it comes as 1 over 3. So moving this 4 to here, it remains 4. Now let's finish up. We have log 2 remaining here, base 2. Now let's multiply out. 1 times 4 is 4 over this 3 that is here. And we have the log 2 base 2. Of course, you know that a whole of this log 2 base 2 is what? 1. So you replace that with 1, you have, that's going to become 4 over 3 times 1, giving us what? 4 over 3 as our answer. That is a simple application of that power of the base law. So we can take example 2 for a better understanding. Now look at example 2, still under power of the base law. Now the power that is on the base is a fraction, 1 over 2. Don't forget, what do to apply this law? You move this power of this base to come behind the log. Now, how do we simplify that? This is going to be, this power 1 over 2 will come behind the log. And don't forget, like we said before, like I said before, when the power on a number is moved behind the log, it is coming as an inverse. Now, let's see what we're gonna have there. This 1 over 2 coming here, you have 1 over. That's the inverse. Now, what do you have here? 1 over 2. As it is coming here like this, it is coming here to become an inverse. So you have 1 over whatever you have here, 1 over 2, log 27 here and base 9. 27 and base 9. Now look at this. How can we simplify this? 1 divided by 1 over 2. Very simple. Just quickly look at this. We have 1. This all over is like saying division. Now 1 over 2, you have it there. Of course, you know, you have to change division sign to multiplication sign. And when you change division sign to multiplication sign, the fraction here, you invert. You change sign and invert the fraction. Inverting means the numerator 1 comes down, denominator 2 goes up. Change sign and invert. So you have 1 times 2 will go up, 2 over 1 will come down. Anytime you change division sign to multiplication sign, the fraction on the right will invert their position of numerator and denominator. So we have 1 times 2 over 1. Let's finish up. 1 times 2 is what? 2 over 1, and 2 over 1 is what? 2. So in place of a whole of these, what do we have there? 2. We have 2 log 27 base 9. But that is not the last answer. You have to solve it until you get to the end. Now look, we have 27 and 9. You simplify these two numbers to its lowest term. The lowest factor of 9, apart from 1, is 3. And the lowest factor of 27, apart from 1, is 3. So what do we have there? Breaking 27 down, we have 3 goes here, 9. 3 divides 9, 3. And 3 goes here, you have 1. So in place of 27, we have 3 power 3. So we now have it there, 2 log, in place of 27 is what? 3 power 3. And for 9, to break down 9, we have 3 goes here, 3, and 3 goes 1. So we have 3 power 2 for 9. 3 power 2 for 9. This has brought a little complicated a step to be solved in this solution step by having two powers, power on a number and power on the base. How do we solve this? It is still the same thing. It is still by applying the same condition or the same law when you have power on the number, and applying the same condition or the same law when you have power on the base. For this, move it exactly the way it is. You have here 3 behind the log. But for 2, as it is coming behind the log, it is coming as 1 over 2. Let's bring this solution to this side. We now have, this is going to be, we're now going to have that this 2 is here. We have 2. This power 3 that is here coming to meet this 2 is coming as times 3. Mind you that the 3 as it is here, you still carry it exactly how you have it here. But for this 2 that is here, as it is coming behind the log, it's coming as 1 over. So you still put times again, 1 over 2 for that one. Now what is left there is what? You have log 3 and base 3. You have log 3 base 3. Now let's simplify this part. You can see this like saying 2 over 1 and 3 over 1. Of course, you know that this 2 down here can cancel 2 on top. What is left there? 2 cancel itself, 1. 2 cancel this 1, this 2, 1. So 1 times 3 times 1 is what? 3. 1 times 1 is still 1. So what you have there is 3 log And for this one you have here, log 3 base 3 is what? 1. Log 3 base 3 there, this will give you what? 3 times 1 equals to what? 3. So the simple solution to that is what we have the answer here as 3. It is very simple. You still maintain the law the way it is. First, move this 1 over 2 to come behind the log. You have 1 over 1 over 2. You continue, then break down 27 and break down 9. So its lowest term, you have 3 power 3 for 27 and 3 power 2 for 9. Now you move the powers away from the number and from the base. You have it here. For 3, as it is coming here, it's coming exactly as 3. But for this 2, as it is coming as 1 over 2. Now log 3 and base 3. You know log 3 base 3 is 1. Multiply, you have your answer as 3. And I hope that is highly simplified. So let's move to another law of logarithm.